On the 2nd of October 2023, scientists working with the James Webb Deep Space Telescope announced the discovery of a new type of planetary object. As reported on Earth.com, link in the video description, NASA's James Webb Space Telescope, JWST, made a groundbreaking discovery of Jupiter-sized planets freely floating in space, unattached to any stars. These intriguing objects observed within the Orion Nebula are referred to as Jupiter Mass Binary Objects, or JUMBOs for short. In a recent detailed survey of the Orion Nebula, the James Webb Space Telescope identified approximately 40 pairs of jumbos. Now, these are mysterious objects which are remarkable for their autonomous movement in pairs, a phenomenon that currently puzzles astronomers. The Orion Nebula is an expansive star-forming region located about 1,400 light years from Earth, a very long way. This star-forming region has long fascinated researchers and has been significantly illuminated by the high-resolution and infrared sensitivity capacities of the James Webb Space Telescope. The origin and nature of jumbos are shrouded in mystery, according to Professor Mark Makorian, the European Space Agency's senior scientific advisor. Let's leave the astronomical knowledge there for the moment, and let's look at the ToK implications of this discovery. Firstly, and patently obvious, this shows that we don't yet know everything. This is patently obvious to those of you who've caught on to ToK, but I'm still amazed by the number of students who view current knowledge as fixed, summary, and absolute. But this discovery shows that knowledge is constantly developing. And that development could be that it is adding to what is currently known, but it could also be that it is challenging what is currently known, and we'll come back to that a bit later in this video. Secondly, this discovery shows that the technology for knowledge production can be crucial. The James Webb Deep Space Telescope is a high-resolution, high-sensitivity infrared telescope placed about, get this, 1.5 million kilometers away from Earth. NASA took it up there on the back of a huge rocket. The production and development of this technology and the Ariane 5 rocket required to put it into space required all the previous technological development and knowledge of historical space imaging up until that point. Without the James Webb Telescope, we wouldn't have found jumbos. And without the prior knowledge development of telescopes going back to the early 17th century, we wouldn't have the James Webb Telescope, and therefore we wouldn't have jumbos. Which brings us to our next implication, which is that the production of knowledge at any single point in time has significant and sometimes unpredictable effects on the subsequent production of knowledge far, far into the future. So if Hans Lippershey had not invented the telescope in 1608 in the Netherlands, we may not have the James Webb Telescope 415 years later. Which is not to say that we wouldn't have anything at all for deep space imaging. We just may now have something completely different. And that completely different thing could possibly be better than the telescope, but equally it could possibly be worse than the telescope. Now, let's briefly return back to the discovery of jumbos for some more great ToK learning. So, these newly discovered jumbos challenge our current knowledge of astrophysics, and they do this in three main ways. Firstly, they are autonomous, which means that they float free from the gravitational pull of a star or a planet. They're not orbiting a planet or a star. Secondly, they come in pairs, and they seem to be paired together, and they seem to move as pairs. Thirdly, they're made of gas. And our current knowledge of gaseous physics suggests that jumbos should not be possible. As Professor Makorian of the European Space Agency says, gas physics suggests we shouldn't be able to make objects with the mass of Jupiter on their own. And we know that single planets can get kicked out from star systems, but how do you kick out pairs of these things together? Right now, we just don't have an answer. It's one for the theoreticians, he says. Interesting ToK language. Theoreticians, it's one for theory. He's suggesting that theory should adapt to the evidence presented, and then that theory will start to explain that evidence. Interesting ToK learning. So what are the ToK implications of this new knowledge? Well, firstly, the ToK implications are for cause and effect relationships, and possibly the cause and effect relationships that we previously thought existed may be inaccurate, or they might even be incorrect. Or those cause and effect relationships may just be limited or bound in some way, and they may be bound in ways that we never even imagined. Secondly, it shows that the body of knowledge upon which current knowledge and assumption is developed is also limited, or it's partial. Again, this seems obvious. As we're developing knowledge, that which is already known is limited, but that also limits the development of further knowledge. So to use the metaphor of the map, we don't go down new roads if we don't know that those roads even exist. As such, we can think of pre-existing knowledge as either an enabler or an inhibitor of the production of new knowledge. And get this, sometimes it can be both an enabler and an inhibitor. Thirdly, the discovery of new knowledge could improve pre-existing knowledge, giving us better and fuller and more holistic understanding. However, on the other hand, the discovery of new knowledge could show that pre-existing knowledge is inaccurate. And as such, we have to change or even reject pre-existing knowledge. Only time will tell which we have to do. Chrissy Sexton at Earth.com summarises the role of jumbos well. She says, as these objects cannot be easily classified as either stars or planets, they represent an entirely new category of celestial bodies, challenging and expanding the boundaries of astronomical knowledge and understanding. So much ToK there. Now, I decided to make this video about the discovery of jumbos at this point because it's highly relevant to ToK Essays number 3 and number 6 in May 2024 session. But it could also be well used for ToK Essays number 2 and number 5 in May 24 session. If you found this video useful, I would be very grateful if you could give me a like, a comment, or even a subscribe. Subscribers are really coming on there. And if you're feeling particularly generous, you could buy me a coffee, link in the video description. Thank you for watching and stay ToKtastic, my friends. Bye.